So very good morning. So let us start with unit number 1 in embedded system. So it is an introduction to embedded system. So syllabus is as follows for unit number 1. So introduction to embedded system, then structural units in embedded processor. So then comes selection of processor and memory devices. Then comes direct memory access. Then we will see about what is different types of memory management methods. Then we will see about what is called timer, what is called counter, and the subdivision of timer bar counter is watchdog timer and real-time clock. Then lastly we will see about in-circuit emulator, target hardware debugging. Okay, so why the word embedded is nothing but there are some software which is specifically written into that particular hardware. So you can see here we have written a program in embedded C. All this embedded C I will teach you if you have interest. Okay, this is nowhere related with your embedded system subject, but if you want we can discuss. So embedded C is little bit easy compared to your normal C. We don't want to face so many problems because everything is in header there. So try to use the header and try to write the program, it will be very easy. Okay, so when a particular software is being hidden inside an hardware, it is called as embedded. Okay, this what I have hidden you cannot identify, and that IC cannot be used for any other application. I repeat, the two things you have to remember. The first thing is what I am going to write is nothing but it is totally hidden. So that is why we call embedded. This has been embedded into that particular controller, and this what I write inside the controller I will not let others to know. So I will embed it here, and this controller cannot be used for any other application, only for that particular application it can be used. Okay, then let us move on to where and all embedded system is there. So nowadays all application has embedded system. So like industrial robot, then comes your GPRS receivers, GPRS receiver and transmitter is there. We are not transmitter, transmitter is from US, so they send the signal, we can use the signal just to say about what is the longitudinal and longitudinal. So GPS tracking systems are there in automobiles, so all this comes under GPS receiver. Then comes your digital camera. So initially your cameras and all, it is like just opening and closing. Backside you have a photochromatic plate, the image falls on the photochromatic plate, it gets recorded. All such things was not nowadays. So entire is digital, you don't have any film and all, so directly written into your pen drive. Okay, so there are so many such devices are interconnected, so obviously you need embedded system. Then is your DVD, MP3 players, then microwave ovens, your Xerox machine, your game, small video games, then set-top box, then wireless router, or in other words all the objects which you see today are with embedded system. Okay, then components of embedded system, what and all you say you can component is, say when you take a controller, first thing there should be something to get the input. So get the input is from sensors. So from various sensors I will get the input. See, when you say as a embedded system should have input, should have output. Input is usually from all the types of sensor, like touch sensor, when you touch it will show. Ultrasound sensor is for speed distance measurement. Then PAR sensor is to identify whether there is any human in that particular area. Then comes speed sensor, then temperature sensor. All this forms an input side. So all this will get the information and they will fed inside. In this, when you see this fingerprint, the ultrasound sensor, PAR sensor, this temperature sensor, you can see all these are not simple sensors, they itself has a microcontroller. Okay, so this fellow will have inbuilt microcontroller, this fellow will have an inbuilt microcontroller, and this will have an inbuilt microcontroller. They are not giving just a sensor itself to us. All the sensors they connect with a microcontroller and they give the output. So that is why I told, and in an embedded system you cannot say you will have a single controller, you will have n controllers. So all these n controllers has to communicate with this. That is why we have to read the unit number 2. Okay, so now here we see that these are the input devices, except this temperature 7, this particular IC, it is only an IC output where you have to do all the calculation inside your controller. Okay, when you move on to output side, first thing is motor. You can connect it to any motor or any relay. So this is a relay, a numeric relay or a mechanical relay. The picture which is shown here is electromechanical relay, but there are numeric relays also. You should know what is the difference between mechanical relays, electromechanical relays, and then numeric relays. In mechanical relays, you don't want any controllers and all. It is all only with respect to mechanical. So that is what there in your automobile on 30 years back. Then what happened is we have moved to electromechanical, where you will have a moving part as well as you have a electrical part. So you give an electrical signal that will energize a coil, and this coil will try to move a part. So there you have a mechanical part is a little bit is there. You have electronics also. So first one only mechanical, second one is electrical plus mechanical, and nowadays there is no moving part at all. It is totally electronics. So that is why you might have seen in 2015 flood, all the cars submerged in water. You have to only throw it in garbage, because it is electronics. Everything will get short. Okay, when water goes in and everything is short, so entire control will go. So you have to replace the entire control system block itself. Whereas in your same flood, you might have seen Maruti 800. If that car, no problem. Only you have to keep the car in dry for some time, and then you can start, because there is no much electronics there. So if the electronics is there, you have to safeguard them. So that is, you have some advantage as well as some disadvantage, and these two is for mechanical conversion. So motor as well as relay, and there should be some display units also. In a car you should have a dashboard. In dashboard everything will be the display, so you need some display. I think you know there are so many types of display, like LED, LCD. Liquid LCD is nothing but liquid crystal, LED is nothing but light emitting diodes. So again you cannot say LCD is waste, LED is good, based upon the application. Okay, some application you require LCD, some you require LED. So based upon that you will have to select, and all this unit also has an inbuilt embedded system. Okay, so when you see this display IC, it has an inbuilt microcontroller. That microcontroller will communicate with the controller which you are using. Okay, so now system we repeatedly say. So we should know what is a system. A system is a way of working, organizing, or doing one or more tasks. For example, I will say you a wiper. I have told car wiper. So car wiper is a system. What is that system? What is the role of the system? To remove water from the glass. Okay, so see, you can place the wiper on the top and make the wiper to move, or you can place the motor at the bottom, wherever or side, whatever you do. But the thing is, what is the role? To remove the water from the glass. See, you might have seen some car where there will be two wipers, but in some car one wiper, in some car one big wiper and one small wiper. So all that will vary depending upon the manufacturer, because all should have some uniqueness. So they will vary in with their system. See, you might have seen some big cars where one wiper will be very big visor and another visor will be small. Okay, but the role, what is the role? They have to remove the water. So a system is a way of working, how we are going to work. So it will vary. System will vary depending upon the car manufacturer. Organizing and doing, so it is organized in a way to remove the water. Okay, doing one or many tasks which is performed in a system corresponding to the fixed plan, program, or set of rules. Once it has been set, it cannot be changed, and once it is set, that controller can do that job alone. So that is what we mean to say. So that is called a system. Then general computing system components. What and all you require? You require a processor, you require a memory, you require an input device, you require an output device, you require a networking unit, how you are going to interconnect them, and an operating system. So that is the final. So I repeat, so general components, what is a general component it requires is, for you, if you ask what you will take, see, I will always compare with human, because highly skilled embedded till now manufactured is only human. Whatever you say, science has not touched 20% of the nature at all. So nature is a big example. So among the thing, you can say the highly skilled product from the nature is human being. Okay, so you can say what is the general computing system for a human, then you will understand this better. So first of all, what you require, I require brain, otherwise I will become a mental student. Okay, if brain is not developed, you all know we cannot do on our own. You might have seen some children that they cannot do their work on their own, depend on parent. That is because brain development is not there. So first and foremost is processor. So processor in our case is brain. So brain is only processor. So you can clearly understand brain is not your brain is not your what to say, that is not, it is also an instrument which is used to control you. Okay, you cannot say a person is dead if the brain is dead. If brain is dead, it is only coma. So processor, you can compare it to your brain. A large memory, again you can compare it to your brain. You have brain has so many memories it stores. So they say from the age of 3 till today, what and all you have done is been recorded. But you cannot say what you have eaten 1 week before. But if there is a situation, then you will remember and tell me, yeah sir, last 4 weeks back he gave the treat in this particular hotel, and that particular hotel, these are the menus, and among the menu I have chosen this menu and I have eaten, and that fellow, see, all this thing you will tell only if I tune that particular portion, otherwise you won't tell. But your brain has, from the age of 3 till now, all the thing is been recorded. One more example if you want, you might be walking in your street, suddenly you see a person, then your brain will say, I have seen this person before. Then you will slightly think and identify, yeah, he has studied with me from first standard to third standard, then he has been gone to some other school. Then you will ask him whether you have studied in the school. Okay, so how you are able to tell that? If that has been recorded in your brain, then only you can tell. So your brain has all the thing. Similarly, for an embedded system, what you want a memory. That large memory or small memory depends upon the application. If it is a small application, you require low amount of memory. If it is very large application, you require more amount of memory. Okay, then input units, we have 5 types of inputs, like they say MIEEE, Kanmuk to Sevi. So all these are input for us. Similarly, there are input for embedded system also. So inputs are like various sensor, like temperature sensor, pressure sensor. So what you observe from your hands are nothing but pressure sensor, and there are so many sensors in your human body also, that they will say MIEEE, Kanmuk to Sevi. So from that you are able to get the input. Similarly here, then output units, you are also having output unit like mouth you have, from which you can express what you want to say, and something you will express by action also if you are not supposed to talk. Okay, that we will usually do in class. When somebody is taking class, you cannot directly open your mouth and speak, but you will do some action and try to make others to understand what you mean to say. Okay, then networking unit, your brain has a networking unit with the help of that blood flow and nerve system. So with that they are able to communicate. What you've been sensed from your eyes will be converted into small dot with the help of retina, then that image will be sent, travel via nerves. Okay, similarly your embedded system will also have output units like display units or speakers. You can put a speaker, for example, when you want to give an alarm, if something is going wrong, your embedded system has identified, then what you will do, you will put an alarm unit, where you cannot say that I have displayed, why you have not seen, because when you are in work, your eye will be on your site of work, and only person who is left free is ears. That we will usually do, we will try to listen something and we will try to do. So if you want to alert them, then you have to alert with the help of output unit like speakers. So networking unit is various types of units to be connected. Then comes the operating system. Operating system, how you can explain with you when you want to say what is operating system which you follow is the language which we say. See, a Tamil people, then Telugu people and Andhra people is there. There is some operating system is required between them. Within the group of Tamil speaking people, you use operating system as a mode of language Tamil. So similarly here we use whether Windows or Mac when it is Apple product, you go for Mac, and there are so many types of operating system like Unix or Windows. So you can select any one operating system. That is, if you are doing with the processor. If you are using with controller, again there are so many operating systems that we will tell you, so that you can even understand. There is even operating system in controller also. But when you want to say an example with human, how different groups are, how among the each group you are going to communicate, so that requires an operating system. Then an embedded system is a system that has an embedded software in a computer hardware. The system is described for either an application or a specific part of an application. So you can prepare an embedded for a application, or in an application that might be a small part. Okay, you have a very big job. In that very big job you have one small job. Okay, again I will say the same application of automobile. So in today's automobile there are around 1000 sensors is there, and there are about 80 controllers are there, 80 to 100 controllers are there, and there is a master controller for all. Okay, so that is the best example. So embedded system is for a particular application or a part of a particular application. Okay, for example, for embedded system products are washing machine, cooking machine, automatic chocolate vending machine, then multitasking toys, like jumping, rotating, crawling, moving forward, moving backward, all such things of toys. So classification of embedded system, there are three types, like small scale embedded system, medium scale embedded system, and sophisticated embedded system. Small embedded system we all know. Example, if you want, you will say the toys. Okay, medium you will say like washing machine, cooking machine, automotive chocolate vending. And for sophisticated embedded system is like aircraft control, your car control, then your satellite control, all that will come sophisticated embedded system. Okay, so basically three, where small embedded system, medium size embedded system, and sophisticated embedded system. Then comes your embedded system components. It embeds hardware similar to a computer, software usually embedded into RAM or flash memory or media card. In some application, see for example, when you are working in an IT company, you may work as a programmer, you may work as a head programmer, or you can be a team member or a team leader or a team manager. Okay, you can be at any post. So all the person will go and sit on the same computer, but all the person are not supposed to view all the content. I think you know. At the bottommost case, he can open his part of the system alone, and when you move up and up the hierarchy, he can see all its lower person's content, and finally a project leader, he can view all the members, and a project manager, he can view all the parts of the programmer, program leads. So what I am saying is, entire software is embedded into a memory card, so you have to insert your card and you have to work. So entire system will be reallocated and it will show only the content which is required for you, remaining will not be shown. So that is how. Even very simple way to explain is, your when you turn on your computer will ask like whether you are a guest or an admin or a specific username. When you type a specific username, then the entire desktop will vary. When you log in on admin and see, the desktop will be different. When you log in as a guest, your desktop will be different, and when you log in with a particular login ID, then that desktop. Okay, so that is also an embedded. So it embeds a real-time operation system. That is what I have told. It is real-time operating system. I will explain it when you come to unit number 4. So on general, components of embedded system are: one is power supply, reset, oscillatory circuit. That is all related with the brain. Okay, you have to give power supply. If you are not giving power supply, what will happen? If you are not eating, what will happen to you? If you are not eating, then there is no energy, because what you are eating is being decomposed or it is digested, and you get an energy, and that energy is only being circulated via blood in a form of glucose, and that is being gone into pancreas, and it will generate insulin, and the generated insulin will be stored in all the places. whenever you want, that will be converted into energy and will be given to you. So what for most requirement is power supply is also requirement. Then your brain has to properly work, that is oscillatory circuits. If this 2% is working, then okay, all other are only components. What is the components are? Processor, timer, interrupt controller, output interface device, then parallel port, serial port. A parallel port, serial port and all is a way of communicating the data. Then program memory and data memory. There is two types of memory. I think you might have studied in 8085 where you had a single memory, and when you see a microcontroller, you might have seen there are two memories. One is separately for program, another one is separately for data. Then system application specific circuit. This will vary depending upon the product of the embedded. What for what you are preparing, then you will try to put this block. Okay, then comes your input. So top is input and bottom is output, and center is nothing but the various blocks which is being used. All these blocks are only memory blocks, and this memory blocks are given with the names, and that each memory blocks will do a particular task. Okay, and this is power supply, and this is system application specific circuit. Again, this I will explain what is system application specific circuits and all. Then this is an important 16 mark question. Building blocks of an embedded system. They will ask what and all the various building blocks of an embedded system with the hardware, with the software they will ask. So first of all, when you start, first one is power supply, I told you now. Then comes your clock, then comes your system timer. System timer is the way in which you are going to execute the work. Then real time clock, then reset circuit. Reset circuit is nothing but, see, when you are working, sometimes what will happen, you might have been asked to read at home, you will go and read and you will suddenly fall to sleep. At that time, what will your parent will do? They will call your name, Ganesh, Rama, like that they will call. Again you will start opening your eyes and start reading. So that is nothing but reset circuit. Even in processor we need reset circuit. Sometimes it will go into loop, or sometimes it gets locked. I think in your home also you might have done, screen gets locked. So what you will do again? You will press the reset circuit. So from first it will start. Then power up reset. There is two types of reset. One is normal reset, another one power up reset. This is like similar to when you go to sleep. This is when the power is being removed, it goes to reset. Okay. Then watchdog timer. Watchdog timer is nothing but you will continuously monitor a thing and then you will report. Then comes memory. Then input ports, output ports, input buses and output buses. Then comes your input output interface. Then DAC, ADC. DAC is digital to analog, ADC is analog to digital. So these are the various building blocks of embedded system. So all this you have to put the heading and write 1 or 2 lines or 3 or 4 lines. If you write, then it is more than sufficient. It is a question which can be asked in 8 mark or 16 mark. But now we cannot know whether your pattern will be like this, so that it may be multiple choice. So in that case this may not be there, but it is a possible question. Then comes your first step in building a processor. The processor is selected from the following consideration. So first thing is you have to select what processor will be useful for your application. See, for all application there is not a single processor. In some case I need more memory, some case I need more speed, sometimes I need very less speed is also sufficient for us. Like that, depending upon the application, speed will also vary. Okay, so the question is, on a processor is selected from the following consideration. So based upon the instruction set, more number of instruction set or reduced number of instruction set, maximum bit, whether 8 bit, 16 bit, 24 bit, 32 bit or 64 bit. See, I need a control for traffic light where I will not go for 64 bit and all. 8 bit itself is more than sufficient. So higher specification for lower job is also waste. Taking a 12th standard student, asking him to sit in first standard and listen and write, he will get 100 out of 100, but that a person who is getting 100 out of 100 is useless, because he has to go and sit only in 11th standard. So you cannot say I will bring a super duper person and ask him to do small silly things. Okay, so for silly things there are a processor, that processor alone be taken to that silly things also. And you cannot say that silly things, sir, by the word itself you have told silly things, so shall we remove that and all? You cannot do, because that is also an embedded. Okay, then clock frequency is the way in which we are going to work speed. So it is started with kilo. frequency kilohertz, then it went to megahertz, then it went to gigahertz. Okay, so some application required giga, some application mega itself is sufficient, in some application even kilohertz is more than sufficient. Okay, then processor ability to solve the complex algorithm. This is like you might have studied, I think, that is fixed point, floating point. I don't know, you might have studied fixed point architecture, floating point architecture. In a fixed point architecture, 3.2 is will be recorded as 3, 3.9 3, 4.1 is 4. So there is no decimal point at all in an architecture where you call as fixed architecture. Whereas in floating point architecture, decimal points are allowed. So that is what they mean to say for solve the algorithms. Then build processor for embedded software consists of following. First we have seen about hardware, now software. So project file consisting of source file, library files. I think you all know what is library file. stdh.h, I think standard input output, like cone.h, math.h, all that comes under library. Okay, then completion of project file, linking, then converting object file into X file. Okay, so this is with respect to software. So you will write a C program first thing, that has to be compiled, then it will be converted into assembly language program. So compiler is to user language to machine language, then assembler, it will add the thing which is pre-required. So it will add object file with the library nodes. Okay, so that is the assembler work. Then comes your linker. Linker will make it as executable file, that is exe file. Then loader will load it into the memory, which is nothing but installation. You might go to net, you download a software that will be in the format of .exe. Just download it in your system. Whether that software will work? No, it will work only after installation. So you can see what has been done. A programmer is doing a small program, then he compiles means he will convert into assembly language. Assembler, your program with the header program will be added. So then linker will make it as executable file, then exe. So all this thing the programmer is doing, and he is trying to generate an app. After this, what happens is an exe file comes into picture. Just downloading this exe file is not at all able to work. You have to load. So loader will again, it will generate the required memory spaces for that app to work, and it will generate various location. It will try to place so many content, and it will utilize it from that, and it becomes an executable file. Okay, so exe file you will download from after the linker is done. Then you have to install the setup and you have to use it. So this is with respect to build process of software. Similar to hardware, this is with respect to software. So I repeat, process is compiler, assembler, then comes linker, then after linker it is loader. Okay. Design process in embedded as continuing. So concept used during design process. There is a design. Design is nothing but the way in which you are going to prepare, that is called design. So first I will sit and write abstract. Abstract is nothing but, see for example, automatic toothbrush. So just take the toothbrush, keep it in your mouth, automatically this brush will go up and down and it will try to do. So if I am thinking of that, then what is my abstract is washing the teeth. That is the abstract. Hardware and software is, what is hardware required? Brush, motor, brush. Software is rotatory motor has to be operated, so that is software. Extra functional property is not there for our application. Then system related family of design, whether you are, when you will upgrade, if upgrade, what family you will go, or what is the level you will go up. Then modular design. See, I have told a small example of toothbrush. If it is a car, then modular design and all will come, because day by day you will add a feature to your car. Okay, on one single day itself all the features is not brought in. I think initially in late 1980s you don't have a motor for your side windows. So then motors came, then you add an up, when you press the up key, then your side glass will go up and down. And then technology even developed further. at the time of when the glass is moving up, if you keep the hand in between, the glass will stop and go down. Again, if you remove the hand, then only the glass will come up. So there will be a change. I cannot say a product is developed, that product will last for 10 years, 20 years. You will go on upgrading. So that is called as modular design. So I will separate each and every task and I will do separately. Then only I can go for upgradation easily. So that is modular mapping, from which output is being given as an input for second process, and second process input for the third process, like that it goes on. That is mapping. Then user interface design and refinement is, that is what I told. Initially you might have done just moving the glass up and down. Refinement is, if somebody keeps hand, it will come down. All such things is called refinement. And initially glass will go at a very faster and it will go and hit the top portion and then it will stop. Now what you can do, initially your glass can be moved at faster speed, then you can reduce the speed so that the glass will not go and hit on the top. All that is called refinement and all. Okay, so when you take software, you can divide it as requirement, then structure, then comes implementation, then testing. So I can divide it into 4. Okay, so linear sequence. First I will model or analyze. I will sit and think what type of requirement is there for my system. Then same case, when you want to buy a laptop or when you want to buy a desktop, first you will, what you will do, you will sit and see the requirement. Because of, see, for a laptop is not same for your father, for you and for your younger brother. Okay, everything will change. Because your younger brother, what you will do, you will just open paint and scribble something in painting. But what your father will do, he will work with respect to his work. So he required internet speed, all that things. Whereas when you see, you will play, so you need graphics card. So that is called a requirement, first step. Okay, I have identified the requirement correctly. Then what you will do, then you will say about what type of softwares you have to load. See, if it is you are going to play with the graphics card, you have to put some other software. When you want internet, some software has to be put. For painting, some software has to be put. That is design. Then implementation, you are doing that fabrication itself. Then testing, you will see whether that is working properly. Okay, you are buying a laptop, but I have told for the embedded class, you are like a CEO, so you design for a particular person. Okay, then design process in embedded system, main design with respect to electrical engineer, we will start talking now. So first one is power dissipation. What is meant by power dissipation? Which is nothing but electrical power conversion into heat. Whether it is allowed? No, it is not allowed. So you will try to reduce your dissipation. So when you want to reduce the power dissipation, obviously, see, semiconductors are not conductors. They are only semi. So in a semi, if a current is flowing, then heat will generate. If the heat is generated, that is called power dissipation. Okay, power is being dissipated. So you have to do all that. How to reduce your power dissipation, you have to sit and think. Okay, then performance, which is mean for a given battery, what is the maximum time it is going to work. Then process deadline, how much fast your system is able to work. Then user interface, whether you are going to give a display, whether what type of display, and whether you are going to connect a printer or all such things. Then size. See, the same mobile phone is manufactured by Samsung and same mobile manufactured by Apple and so on. One will be in small in size, one will be in large in size. That is because of the technology what is used. Then engineering cost. Engineering cost is nothing but your production cost. Then comes your manufacturing cost. Engineering cost and manufacturing cost. Manufacturing is at lot when you are going to produce, that is called manufacturing. Engineering cost is for one piece. Okay, then comes your flexibility, how flexible is your product. Then prototype development. After all this process only, I go for developing a prototype itself. Then I will make it to circulate in market and I will try to identify what is the time for which my product will be bought by the consumer, the system, then user safety and maintenance. All such things I will take into consideration. So when you see, first thing where you will start, you will think whether your embedded is really required by the end user. That is called requirement. So you have to sit and think first. Directly I cannot go on ink. So before ink I have to think Okay, go on, think, and then ink. Okay, that is what we say. So you have to sit and think whether the embedded system which you are preparing is really required. Then you have to tell about the specification. So when you want an embedded product, what and all that your embedded product will do. See, if I am preparing a particular product, what that product will do, that is called specification. Then to do that process, for all that process, what type of architecture I am going to use, then the supporting component, then final system integration, the embedded product will come into your hand. You give it to an end customer, customer says some complaint, then that complaint will be going into component level or architecture level or specification level. When it goes to requirement level itself, what you have developed is waste. Okay, so from starting from requirement, then specification, then architecture, then component, and then system integration. So this till this what we have seen today. So with this today's section we will try to wind up. If you can ask me the